Okay. Good morning, everybody. Let's see. We're going to start with the projects are over, so let's talk about a few uses for if statements combined with loops, and if you have questions, send them in. Okay, let's make a new class. Okay, this time let's do something related to the lab. Let's do some multiplication, division, etc. with functions. So first, let's make a method that multiplies. We're going to return a double this time. And we'll take in 2 doubles. So, think about this. With doubles, can we use those in a for loop? Can we use those in a while loop? How do we multiply those by doing repeated addition? Well, we'll take the first number and we'll loop it through the second number of times. And we'll see how that works. So let's try this out with a for loop. I'm using I just because it's conventional, but we can always use counter. And feel free, of course, to follow along on Eclipse. So in this case, I have a loop that goes through b number of times, b times, and it'll increase by 1 each time. So let's see how we can do this. We can say, okay, well, what are we going to have? We're going to have a product. And I'm going to talk about a caveat with this in just a second. So every single time we're going to increase the product by a. And this will work sort of, but there are a few issues with it that I'm sure you can figure out. And if you can see the issues right now, before I test it, feel free to type them in. Now, to use this, I'm going to make a quick print method. Okay, so I just overloaded the print this new method I made called printLine, and it will basically perform the function of printLine for our purposes. So let's first try multiplying 3 by 5. I print out and I get 15. So that's correct. If I try 3.5 times 5, it should get 17.5 here. Some issue is happening because we have an int product here. So this should be a double. We have to return a double. It won't complain because an int can be converted to a double with no loss of information. But in this case, let's see what happens if we try this with the double being returned now. Oh, we got 17.5. That's great. We've covered decimals in our first number. What if I try negatives? Well, in the first number it works. If I try the second number, oh, that didn't work. Why didn't that work? The reason is because we're saying, okay, well, while I is less than b, I has to be increased and will run the loop, but b is -5. So we have to think, okay, well, maybe there's some other way to do this where maybe I'm doing the absolute value of b, and if it's negative, I'm going to multiply by a -1. So maybe what I can do here is say, if b is less than 0, so this is sort of tricky because we've used a negative value here, and we've used a multiplication symbol. Let's see if it works, and then let's see if we can translate this to something where we don't necessarily have this negative, or this multiplication. So this will work if we have both negatives, if we have one negative. So that took care of the negatives. We still have an issue with the fact that we're using a multiplication in our multiply method, because that seems a little unfair. We're trying to do it just with addition. So we might need 2 loops, right? We might need 2 loops, or we might need to change our I. Okay, so, well, we could change this value here. So we could say if b is greater than 0, we'll do this. Otherwise, if b is less than 0, b is greater than or equal to 0. Doesn't really matter there. If b is less than 0, we won't multiply our product by 1. We'll take the same loop and, instead we'll say b here. And then we'll say, okay, well, maybe this goes a minus minus, and maybe this goes 0, and this goes greater than. but we're also going to have to subtract a in this case. Let's see if this works out. And think about why I would have to make those changes. 0, 0. Okay. Because we have math.apps here. And we'll get our correct result. So this is a very complicated thing, and it can't even handle the second thing being a double. 5.5, I'm still going to get, oh, well, that worked out okay. It went a little far, I believe. So 5.5 times 3.5 is 19.25. You can see I didn't get the right answer there. Should use smaller numbers here. So let's see if that happens if I do this. I still get 21. What happens? It goes through the loop one extra time. And it adds not a fraction of a, but the entire a. So if you can think of a way to fix this issue, it can be awesome. I'd like you to try to do that on your own. That's the last issue with this. We've taken care of negatives in both a and b. We've taken care of decimals for the first number. Now, how do we take care of decimals with the second number? That's my challenge. And the question is this the right type of loop? Am I adding the right thing? Am I subtracting the right thing? Can I actually do this effectively? Okay, that's my multiply method. Let's try something else. You'll notice that I have a print line that handles integers, that handles doubles, and that handles just objects in general. But I could take that. So I have 3 different methods. But they all do the same thing. They just print it out using the print line, the standard print line. I'm just taking out that out.print line. Okay, let's try a division method. Well, what is division? Well, I'm going to take in a double A and a double B. We have to have a quotient that comes out. And then we'll return that quotient. Now, how do I do repeated division? Feel free to jump in and try it out. You can always pause the stream, come back, and look at the solution. Okay, so how would I do this? Well, repeated subtraction. But it's not just repeated subtraction, is it? It's really counting how many subtractions go on. So let's try that out. So for loop or while loop? For loop or while loop? Let's try out a while loop. Well, b is greater than, or let's say, well, a is greater than 0. And we'll do a counting of how many times this happens. Okay, and then we'll find the remainder by doing something like this. Well, well, let's see what happens first. We're just counting our quotient, or our number of times we do this. And instead of printing the multiply, I'll print a quotient just with some basic variables to start. Or basic numbers. 4 divided by 2. Ah, what did we do? Oh, quotient int. Yeah. Or not quotient. Divide. That's my problem. Always use the right name. And I get 2.0. 4 divided by 2 is 2. I'm counting how many times I do this. Well, what if I say 4.1? 4 divided by 2. I get 3. So there seems to be an issue where perhaps our loop needs to be a little more sophisticated. Well, a is greater than 0, and a minus, really what we're looking at is, well, a minus b is greater than or equal to 0. Because what's happening is we want to know when we're getting below 0 and when we're not. And when we're not, then we know we're in good standing and we're adding to our quotient. So now we're going to underestimate if we have this situation up here, 4.4 divided by 2. We're going to get 2. And that's fine because now we can find out some sort of remainder. And this is going to be cheating a little bit. We're going to be using the modulus operator. But what I can say is, now that a is low and b is sort of high, I can say, okay, well, what is the result of a% b? And really, that's not that bad if we're saying, okay, well, a is some fraction now out of b, and that's going to be our decimal point. So now I can say quotient plus equals a% b. Or really, a% b is our remainder. So it's almost like we have to say, okay, well, I also need to return a remainder. If I wanted to return this as a decimal, it would be really convenient, but instead, I feel like, perhaps it's a good idea to have a fraction class. And this is back in a day when we had that fraction class, right? So I don't have it here, but I can certainly return some sort of fraction. But let's see what happens if I just do this. I'll probably get some number that's too big, right? 2.4. That seems to be okay. Is 4 divided by 2, 2.4. 2.2. So it seems like we're still off. Yeah, so we'd have to actually use division for this decimal part. And there's a way to get around that, but we're not going to really discuss it right now. So I have a quotient that mainly uses subtraction for whole numbers. But again, we're not necessarily doing it properly for anything beyond that. And that should work. 2.3 should get us to, yeah, something a little lower. Does this work for negatives? -2, 2. Yeah, it seems to work for negatives. So it's almost like the division is in some ways easier than the multiplication because the subtraction handles the negatives and positives. This is a condition that still works. And we're just subtracting until we go below 0. Or we get above 0, really, in some cases. Okay. So that's our quotient method. How would I use these in something a little more complicated? Let's see, how would I use these in, oh, well, maybe not more complicated, but public static void, not void, double area of a rectangle. So I'm going to make a double width and a double height. And here, I'm going to just say, well, for a rectangle, I'm going to return with multiply using my multiply method. Width and height. So here, if I want to know the area of a rectangle, of -4, -2, I get 8. Now, the issue here is that area of a rectangle should only take in values that are bigger than something, bigger than 0, right? Because we can have a width that's less than 0. So here, what I can say is if either one is less than 0, something like this, where I throw an illegal argument exception, I crash the program, if I have negative values. So here, it'll crash the program. You cannot have negative measurements. There's another way around this. It happens beforehand. So I have protection now inside my area of a rectangle, and to some extent I could change this around. I could remove this. I could say system, I could use my print line method. And then I'll return some sentinel. This is like sort of almost a sentinel value, but it's an error message here. I'm returning -1. You can return 0, you can return anything else, but I'm going to say -1 means you've given me a bad value. Because my area should never be negative, this tells me something's wrong. So you cannot have negative measurements. -1 is returned. If I don't want to print this, I just want to use it, what will happen? It'll just say you cannot have negative measurements, and it won't print out the -1. So one of these pieces is printed out automatically with my print line, and one of them is used by my program, and if I don't want it to be used, I won't save it to anything, I won't print it out. Okay. So we have a number of methods already, and notice we can We have a ton of these. We could turn this into a class, or put these into a class and then use them in here, but for now we're just going to have them float around. Okay, so let's try another method. Oh, also notice I'm not doing any looping on input here because the input is up to the user, whether they put in -4 or -2. I'm not going to be able to ask them for a new value. I mean, I could, but that's not my responsibility. That's their responsibility to put in something valid and to know my method and the documentation. So as a result, maybe I should clarify my documentation. I can do java.comment, or a java.comment here. I'll press return. And you'll see there's something that pops up at param, and at return. It'll automatically read the fact that I have two parameters, width and height, and a return type of double. Return the area based on dimensions, -1 if invalid arguments. So that gives information to the user. So I'm making my comments in this way. I'll show you how this appears to the user in just a moment. Okay. So area of a rectangle calculates the area of a rectangle using the multiply method. So we have all this information saved. That's a reasonable comment. It gives us plenty of information. Let's see if it pops up if I mouse over. Double area, or double loops and conditionals dot area of rectangle. It tells me where it comes from, loops and conditionals, and it tells me that it's called area of rectangle, and it comes with double width and a double height. It calculates the area of a rectangle using the multiply method. The width represents a width, must be positive or 0. Same with height, and it returns the area based on dimensions, -0 if invalid arguments. So I've provided this information. I wrote this. So someone can use this and know what they're using. And once that's there, it's their responsibility to use it correctly. I've done my job. Okay, and I should make the same types of comments here, and you can fill them out above every method that you ever write. And this will be the case going forward with future projects. Now, let's look at an example of maybe using the divide method. Or maybe, yeah, let's use the divide method. Radius from area. So we'll take in a double area. And this obviously deals with a circle. So how do I take in an area and do something with it to get the radius? Well, we have to do a little bit of math. First, we'll divide by pi, and then we'll take the square root, right? So we have to return math.pi. We'll do a divide. And it doesn't matter the order. We'll divide the area by math.pi. And then around that, we'll take the square root. And notice I haven't written that myself. It's slightly more complicated, so we're going to just roll with this. Why does it say this? Because I haven't used my radius from area method. And notice it's giving me an error because I only have one argument here. And so I can only have one argument up here. Let's say I have my radius, and the radius, or the area is 4. Maybe let's call the area 3. And nothing happens, so I have to actually print it out. And I'll get something close to 1. If I actually put in as my area, I get 1. Math.pi divided by math.pi, taking the square root, gives me 1. Let's say math.pi times 100. I should get 0.01. Because I'm dividing the wrong things. I have to say area divided by math.pi. Now that should make more sense. 10. 10.09 is just some rounding error that comes with doubles. Doubles do sort of an estimated division that we're not really going to get some perfect value out of all the time. Okay, here I'm going to say if area is less than 0, return -1, and we're also going to area cannot be negative. So here, if I have an area of a circle, an area of 5, I'll find that my radius is 1 point something. If I try to have an area of -5, area cannot be negative. Okay, so this should work whether I have 5.4 or 5, even though it's using my divide method. If I run it with causative, it'll give me the actual value. 15 should give me a radius of about 2. 2 point, so we divide by 3.14, and then we take the square root of about 5, and that gives me about 2.2. Okay, so I've gone over a number of methods at this point, and I've sort of gone over this java.comment style for methods. And these methods have used if statements and loops. Now, in general, being able to read through this stuff is very helpful. And being able to write it is more helpful. So if you want to go through, watch this again, try to figure out how to come up with these methods or how to write them, you're welcome to do that. I'm going to do 1 or 2 more, just loop functions, loop methods, and we'll see how those work out. And then I'm going to sort of call it a day. So to start out, you may see Fibonacci. And Fibonacci is sort of this sequence to add up numbers that come before onto numbers after, etc. And so we'll print okay, so Fibonacci 10 would give me the 10th Fibonacci number, which should be 55, I believe. Okay, so in this case, we're returning some integer, and we're taking in some integer. Okay, and what we can say is that we have a few numbers here. We have an int start, that equals 0. We have an int first. Let's call it int n. Int start and current. And that'll be 1. And those are our initial conditions to make a Fibonacci number work. Now, a Fibonacci number is something like this. It's a number in the sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, etc. We're taking these two, adding them up to get this. 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 These two, adding them further. And if I want to write this, well, first I've given myself a limit. And that limit is going to be the number I want to stop at. So I'm definitely going to have a loop here. Maybe I'll try a while loop this time. And I'll have a counter. When my counter is less than the limit, well, I'll increase my counter. And I can say, oh, let's try some here. So I have my sum is going to be current plus the number before. My start value is going to change. It's going to shift down to current. And then my current is going to equal my sum. Okay. And then counter plus plus. So I should be able to get my number at the end by doing this. Let's try returning current. And I'll run this. We'll get 89. Now, is that my 10th number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one beyond. So maybe we'll say that my counter starts at 1. And that'll give me the right value. From 1 through my limit, I'm going to be doing this process of adding my current to my start and printing out, and then shifting everything over so that now I have my start being 1 and my current equal 1, then my start equal 1, my current equals 2, then my start equals 2 and my current equals 3, and I'm adding those up to get my next value. And then I'm setting my next value to my current, and I'm setting my start to what current was. So I'm always taking those previous values and adding them to my current value, and then that's my next value. And instead of sum, maybe I could call this next. Three values: start, current, and next. And this is a very common algorithm. If I want to find, let's say, the 20th, it would be that. If I want to find the 100th, it would be too big for integer. So we would shift to doubles then. Maybe I'd have a double here, and I'd have some doubles here. But these blow up really fast. It's almost exponential in a way. Sort of a limited exponential. Okay, so we have 55 here. You could discount this as an actual number, and you could say, oh well, then counter equals 0, and we get 89. But either way, we're doing this process. We're adding up over and over. We're using a loop. And there's a problem on projecteuler.com where, well, we want to stop at the one where we have some sum of these, and it's less than 4, for all the numbers less than 4 million. So while current is less than 4 million, and then we can get this out. So we're just making a modification of this. So instead of adding up all of these numbers and finding the next number, we're still going to do that, but we're going to add them up again, all of the even numbers, let's say. So if I want to add up all these even numbers, I use current %2 equals 0. So if current is even, I'll add it to my sum. So this is sort of complicated, but in the end, we get this one value, or perhaps so this is sort of a solution, a way to solve a problem that's posted to this site, Project Euler. In Project Euler, you go to archives, you sign in, you make an account, then you can see different problems. If we list all the natural numbers below 10 that are multiples of 3 and 5, we add up the sum, we get some value, and then we can submit an answer. And you can run through and try these out. They're really good for practicing loops. So even Fibonacci numbers, again, we get something like this. So they're saying we start with 1 and 2, the first 10 terms will be this. If you start with 1 and 0, the first 10 terms will be something else. So if we change this to 1 and 2, I'd get something different. And that would sort of follow along with what we're aiming for here. But I'm still going to add up all of the terms below 4 million and, maybe return the sum of the even value terms. So I just completed that. That's what this would be good for. And you just type in this number and you'd be able to submit it for, points on this website. And again, you'll notice a lot of people have solved the first couple, and then that number dwindles as we go on up to the last problem, which they keep adding, by the way. 57 people have solved that. So sign in, try it out, and it's good practice for looping. Okay. So I'm going to call it for now. If you have any questions, feel free to email me, and I'll see you in the future.